Okay, so I'm going to take you through how to calculate magnification. So please make sure that you have this paper out and ready to go. And really on the first page, the two most important parts of this are going to be your formula for magnification, and then also these useful unit conversions, because we're going to be using those throughout. So feel free to reference this page as you're working through. I do want to say that if at any point, if you kind of understand what's going on and you know how to do it, you don't have to watch the whole video, but I am going to go through all of the problems. So let's get started. Okay, so here is the first problem. It says calculate the diameter of the nucleus if the magnification of the image is, and I believe that's 10 million. Yeah, 10 million. Okay, so it says write the magnification formula. It's going to ask you to do this every time. You don't have to do it each time, but it is a good formula to remember. So the formula is magnification equals measured length divided by actual length. And that's going to look different for different parts of the problem. So this one wants us to rearrange the formula for actual length. And I'm sure you can do this. Something that you can kind of remember here is if you know how to use a formula triangle, this would be measured, this would be actual, and this would be magnification. So, and I'm just gonna, moving forward, I'm gonna abbreviate, but this will be actual equals measured over magnification. And now what it's asking us to do is use the rearranged formula to calculate the actual length. So what we're gonna do is we're gonna look and see, it gave us a ruler here in our image, and so it measures about 70 millimeters. So that is our measured. And then we're going to divide it by our magnification, which was 10 million. And so when we calculate this, it's going to be 0.123457, and that is going to be in millimeters, but we're going to convert this into nanometers. And so when we do that, we're going to end up with 7 nanometers. Awesome. Let's move on. Okay. So here it says calculate the magnification of the image using the scale bar if the scale bar is 100 micrometers long. And then it wants us to calculate the actual length of the Palisade mesophyll cell. So first thing is magnification formula. So magnification equals measured over actual. And we are going to calculate the magnification first. So when we're calculating the magnification first, when it's not given to us, we're going to use the scale bar, which is down here, okay? So our measured, so measured is like what we see with the actual ruler, like what is the ruler measuring? So we have for this one a measured length of about 10 millimeters. Now, the thing is, it can't stay in millimeters. We have to convert it to micrometers. And how I know it's micrometers is that it's going to have that right there. Okay, so going from millimeters to micrometers, we are going to multiply this by 1,000, and we are going to end up with 10,000 micrometers. And then our actual is, what did they tell us that how long is the scale bar actually? Well, it tells us in part A up here at the top that it is 100 micrometers long. So what we're going to do is, in order to calculate the magnification, we will do our 10,000 micrometers divided by 100 micrometers, and that's going to give us a magnification of 100 times, or 100x. Now the next part is that we're going to calculate the actual length. So it wants us to rearrange the formula. And again, I'm just going to abbreviate. So actual is equal to measured over magnification. So now we're going to use the actual length of the specimen here and the magnification that we just calculated. So you have two options here. If you're looking here at your paper, you're going to see that it's roughly 55 millimeters. You can either convert it at the front end, so you can do 55 times 1,000 and then use the micrometers, or you can wait until the very end. Go ahead and divide and then multiply by 1,000 to get micrometers. So I'm going to show you actually the second way first. So we have a measured length of 55 millimeters. We're going to divide that by our magnification, which is 100x, and that's going to give us 0.55 millimeters, but again, it can't stay in millimeters because it gave us those micrometers. So we're going to multiply by 1,000, and we're going to end up with 550 micrometers, and that is the actual size of that image. All right, let's keep going. All right, we're going to do something very similar here. In fact, for the rest of this, it's going to be pretty similar across the board. So magnification equals measured over actual. So we're going to use a scale bar. So our scale bar measures out to be about 15 millimeters. And we're going to convert that. And this time, we're going to convert it to micrometers again. And if you're like, well, how do you know? It's really little, but it's right there. And that's how we know which one to use. So we're going to multiply this by 1,000, and we'll get 15,000 micrometers. And then our actual is, let's see, 0.5 micrometers. So now we can do our measured divided by our actual, and we are going to get a 30,000 times magnification. So this is magnification here. And now we're going to do the same thing that we did before, where we're going to calculate the actual length of that image, which is an E. coli bacterium. So our formula would be actual equals measured over magnification. So our measured, if you look at the length of the specimen here, okay, it's going to be about 65 millimeters. For this one, I'm going to go ahead and I'm going to convert this first. So I'm going to do times 1,000, and that is 65,000 micrometers. And then, so that's going to be your measured, and then we're going to divide that by our magnification, which was 30,000. And so this is going to give us approximately 2.17 micrometers as our actual length. Hopefully you're starting to get the hang of it by now, but if you're not, keep watching. If you are, you don't have to finish. There's two more. You don't have to finish the rest of this video if you feel like you've got it. You can go ahead and keep on, and then you can come back and check your answers if you'd like to, but we're going to move on. All right, this is the same thing here. So measured over actual to get our magnification. Our scale bar is measuring about 20 millimeters, which in this case, I want you to be careful here. We're not going to multiply by 1,000 because we're working in nanometers, which are much smaller than micrometers. And so we're going to actually multiply this by 1,000,000. So we have a measured length of 20 million nanometers, NM, nanometers. And then our actual is given to us, and it's 0.4 nanometers. So 20 million divided by 0.4 nanometers is going to give us a really large 50 million times view. Which, if you think about it, this is a mitochondria, and we're seeing it super up close. So a 50 million times magnification actually kind of makes sense. All right, so we're going to do actual equals measured over magnification. So our actual measured amount here for this mitochondria is about 50 millimeters, but we're going to go ahead and we're going to multiply that by 1,000,000. And remember, you can wait till the end if you'd like, but 50 million is our measured length. So this is measured. And this is going to be in nanometers. And then we're going to divide that by our magnification, which is also 50 million. So this is going to give us an actual width of 1 nanometer. Excellent. All right, for this one, same exact deal. So I'm going to skip writing the formula, but we're going to start using the scale bar to calculate the magnification. So our measured scale bar is about 15 millimeters. 15 millimeters. Now I want you to, again, notice here that this time we're using a much bigger scale here. This is centimeters. So what we're going to do here is we're actually going to divide by 10. So this is 1.5 centimeters. 1.5 centimeters. And then our actual is 2 centimeters. So 1.5 divided by 2 gives us 0.75 as our magnification. And this also should make sense because we can see the whole leaf and we're not looking at something super tiny. And so we're looking at a 0.75 magnification. So for actual, it's measured over magnification. So our measured length of our leaf here is about 35 millimeters, which is 3.5 centimeters. So we're going to take 3.5 centimeters and we're going to divide it by 0.75, which is our magnification. And we're going to end up with about 4.7 centimeters. Okay, that's it for this. So if you need more help, then please let me know. But now you're going to make sure that you can do the problems on the lab practical page.